In the last class, we have been studied about the bonding in carbon. Now we are going to learn an interesting topic known as homologous series. Okay, we know that carbon atoms can be linked together to form chain of varying length. Okay, this carbon will link together and form various chains. Okay, now we can learn about what is homologous series. Okay, we have been learned about the valency 4 of the carbon, and this will connect to form various compounds that we have learned about the bonding and all of carbon. Now we can look at the term homologous series. Okay, and what does a homologous series represent? So, series having similarities. Okay, homologous series means series having similarities. And what will be the similarities of this series? What are the things that should be in similarities? So let us see. Here we can see homo means same. Okay, so homo means same and series means a sequence. Okay, so there should be something that will be same in this series. When we consider some molecules, we can see there will be something that is same for all the compounds or molecules. That is functional group. Okay, so functional group, the group attached to the carbon, they are known as functional group. Okay, so there will be same functional group for all the molecules or compounds. So when we look at series, series means a sequence or succession. Okay, succession means one after another. Okay, so there will be a sequence or succession. So let us see some examples. We are familiar with alkanes, isn't it? These are some alkanes: methane, ethane, propane and butane. Okay, now we can see that there is one carbon attached to covalently bond with 4 hydrogen atom in methane. Similarly, ethane 2 carbon atoms, propane 3, butane 4. Okay, so let us write the chemical formula for each atom, molecule. Okay, so we can write the molecular formula for each molecule. For methane, it is CH4, 1 carbon attached to 4 hydrogen. Ethane C2H6, propane C3H8, butane C4H10. Okay, so these are the molecular formula for these alkanes. In these alkanes, all the bonds are single covalent bond. Okay, you can see there are single covalent bond. So methane is the basic alkane. So CH4 is the formula for methane. When we add a CH2 group to methane, we will get C2H6. That is 2 carbon. So it became ethane. Okay, so when we add a CH2 group to methane, we will get ethane. And when we are taking the second case, ethane, that is C2H6, and we are going to add one CH2 to this ethane, we will get it as C3H8. Okay, C3H8. That means that is propane. Okay, the 3 carbon atoms are there, so they become propane. Then we are going to add CH2 to propane. We will get C3H8 plus CH2 gives C4H10. Okay, C4H10 is butane. And now we are going to add CH2 to the butane. Okay, butane means C4H10. Okay, similarly, by adding this, we can see that there is a common functional group. Okay, for these alkanes. This is in these compounds we can see single covalent bond, so they are known as alkanes. Okay, so they have a common functional group CH2. they have been added in this group. So we can write these alkanes in a general formula CnH2n plus 2. Okay, this N is the number of carbon atoms. Okay, so by writing then which number we want to given at the position of N, we will get the chemical formula for every molecule of alkanes. So CnH2n plus 2, that means CH4, C2H6, C3H8, C4H10, etc. Okay, you can see they can be represented by the formula CnH2n plus 2. And here the common difference is CH2. So this is a homologous series. Okay. So let us define homologous series. Homologous series in which the compounds with the same general formula but different molecular formula occur in immediate succession. Okay, succession means one after another. Here you can see the methane, ethane, propane, butane. Okay, these all compounds are different bond length, but they have similar chemical formula. Okay, and they occur in succession, that means one after another. So they have same functional group of CH2. Okay, they have been adding a CH2 group, we will get it. And now can you say, does the properties will be same for all these molecules in a homologous series? Absolutely not. Okay, the physical properties may vary according to the difference in chain length, or we can see that the mass also increasing, the molecular mass also increasing. But here we can see that the chemical properties are maybe similar since all the functional groups are same. Okay, here in a homologous series all the functional groups are same, so we can say that they can be chemical properties, similar chemical properties, but there is a gradation or different in physical properties such as melting point, boiling point and solubility. Okay, in this methane, ethane, propane and butane, we can see that the chain length are increasing. For example, when we take a chain of 10 carbon atoms, we are going, and a carbon molecule of 3 carbon atoms, okay, chain of 3 then the energy required to break this bond, okay, will be higher for 10 carbon atoms. Okay, these 3 carbon atoms can be broken easily, so there will be changes increase when carbon chain increases, this melting point, boiling point, etc. increases. So methane, ethane, propane, butane are the homologous series with a functional group CH2. Okay, so you have got an idea about homologous series. Now try to write homologous series of alkene and alkyne. Now we can move to allotropes of carbon. The main allotropes of carbon are diamond, graphite, graphene, fullerene, etc. Okay, these are the main allotropes of carbon. This will have different structural forms of same element in same physical state. Okay, this will be compounds of same element. Here it is carbon. All the atoms in these compounds are carbons, and so that they will have different structures. Okay, in these diamond and graphite have joint covalent structures. That means all the atoms are covalently bonded in it. In the case of diamond, each carbon atom is covalently bonded to 4 other carbon atoms. Okay, so it will obtain a 3-dimensional pattern. Okay, so we can say that carbon has a valency 4. All the 4 valencies are covalently bonded. So covalent bond is very strong. So diamond is very strong and hard in nature, and it have high melting point, and so that it does not conduct electricity since 4 valency has been filled. No free electrons or ions are present in diamond, so it does not conduct electricity. Now we can consider the case of graphite. In this graphite, we can see that each carbon atom is attached to other 3 carbon atoms and forms flat sheet. Okay, and this flat sheet has been layered to form graphite, and there is no covalent bond between 2 layers. So these layers can be movable, so that this graphite is very soft in nature. Since each layer is covalently bonded, they have high melting point. Each layer is covalently bonded. Okay, so in diamond 4 bonds are there. In graphite only 3 carbon atoms are linked together, so there is 1 electron free. Okay, so this will be moving inside this graphite, that means delocalized. We say it that such as delocalized. So it conduct electricity and heat. Okay, there is a 1 electron inside graphite, so they conduct electricity. And each layer of this graphite is known as graphene. And from this graphene we can construct various structures known as fullerenes. Okay, from this graphenes we will form fullerenes. Now we can look at fullerenes and graphene. Now we have said that the allotropes are different structural forms of same element in same physical state. Okay, so we have said that learn about diamond and graphite. They have been so in the case of graphite, there are various layers. Each layer is known as graphene. Okay, so each layer is known as graphene, and they are strong. Each layer is very strong since there are 3 covalent bond and 1 delocalized electron, and since they can conduct electricity. Okay, there is 1 electron, so they conduct electricity in the case of graphene. And this graphene is always seen in nature in the form of graphite. Okay, so this graphene can be molded into different shape. First of all, it can be converted into tubes, or it can be converted into spheres. These are known as fullerene. Okay, so these are known as fullerenes. So these fullerenes can be these fullerenes are used in various drugs, since they can be form spheres around the medicine or molecules. Okay, so they are used for covering medicines. Then since it have a large surface area, this has been used as industrial catalyst. Okay, they have been used as industrial catalyst for speeding chemical reaction. Also, this nanotube is used in nanotechnology. Okay, nanotechnology for strengthening materials also. Nanotechnology such as electronics for giving strength, this badminton bat etc. will get through this nano materials. And also it have high strength without adding any weight. And these spherical shape fullerenes are known as Buckminster fullerene. Okay, Buckminster fullerene, and this is a hollow sphere containing 60 carbon atoms. So the formula is C60. It contains 60 carbon atom. It is used in medicines, batteries, food, fashion, etc. These fullerenes are used in various areas. Okay, so now do these questions as homework.